So we'll start gear train today. So basically your gear train is a combination of number of gears you can write gear train is a combination of gears used to transmit motion from one shaft to another and gear train is required for a large speed reduction within a smaller space, within a smaller available space, while transmitting power. Okay. Now what are the different categories of gear train? So types of gear train. So the types are first is simple gear train, second compound gear train, third is reverted gear train, fourth is planetary, or epicyclic gear train. Okay, now we'll discuss one by one. So first is your simple gear train. Okay. So the schematic will be like this. Let's say we have a larger gear wheel. Okay. Rotating about this point, it is gear 1. Okay, it is rotating in anti-clockwise direction and it is connected with gear 2, which is rotating about this point. Okay, so this will rotate in clockwise direction, obviously. This is gear 2. Then third gear is somewhere here, suppose. Is fixed about rotating about this point, so this will rotate in anti-clockwise direction. This is gear 3. Okay, then fourth gear is somewhere here. It is rotating about this point. Okay. And it is in clockwise direction. Rotation is in clockwise direction. Then fifth is attached to the 4. Okay. Suppose this one is fifth and it is fixed about this point, so this will rotate in anti-clockwise direction, and it is gear number 5. Okay, so in general, a simple gear train is when a number of gears are used for receiving and transmitting motion from one gear to another the arrangement is called simple gear train. Okay, the following things are generally observed in the simple gear train observations. First is two external gears of pair always move in opposite direction. As you can see in this figure, gear 1, okay, the first external gear is rotating in counterclockwise direction. Okay, two external gears always move in opposite direction. Okay, and second one is rotating in clockwise direction, this one. So opposite gears will always rotate in opposite direction. Okay, second, all odd number gears move in one direction and all even numbered gears in opposite directions. That is gears 1, 3 and 5 in this particular case move in counterclockwise direction, clockwise direction, and gears 2, 4 move in clockwise direction, okay. Then third is the speed ratio. Speed of driving, it is denoted by speed of driving to the driven shaft. Is called speed ratio. Okay. Reverse of speed ratio is called the train value. Remember this. Reverse of speed ratio is train value. Okay. Let capital T is the number of teeth on a gear, and N is the speed of the gear in RPM. Then we can represent this as N2 by N1. Ratio of the speed is equal to T1 by T2. N2 by N1 should be equal to T1 by T2. Okay. Or we can say omega 2 by omega 1 is equal to 2 pi N2 by 2 pi N1 is equal to N2 by N1. Okay. Because of this, similarly we have N3 by N2 is equal to T2 by T3, and N4 by N3 is equal to T3 by T4, and N5 by N4 is equal to T4 by T5. Okay, so multiplying both sides, you'll have N2 by N1 multiply with N3 by N2 multiply with N4 by N3 multiply with N5 by N4 is equal to T1 by T2 into T2 by T3 into T3 by T4 into T4 by T5. If you simplify this, it will be N5 by N1 is equal to T1 by T5. For this particular arrangement, as per our schematic, we are going up to 5. Okay, so this left hand side is known as your train value. Train value, which is equal to n5 by n1, okay, and which is equal to number of teeth on driving gear divided by number of teeth on driven gear. Okay, so this speed ratio is 1 by train value. It is the reverse of the train value. Now from this above relations, it is seen that the intermediate gears have no effect on the speed ratio. Okay, therefore they are called as idlers. Okay. Normally you will get question on this, that prove that the intermediate gears in a gear simple gear train have no effect on the speed ratio. Okay, so you have to derive this whole thing for this. Now second one is your compound gear train. Okay, now the schematic of a compound gear train you can draw like this. Let's say we have first gear, okay, and this one is connected with the larger second gear, okay, attached to a shaft, and first gear is attached here, and this is say 1, okay, and this outer one is 2. Then with the same shaft where gear 2 is attached, another gear is attached, okay, which is gear 3, and this one is, let's say, 3. Okay, now another gear is connected to gear 3, let's say like this. Okay, this one is gear 4, and it is connected with a shaft at this point. Then with the same shaft, let's say gear 5 is connected, okay, and to 5 gear 6 is missed like this, and it is fixed somewhere here. So this will be gear 5 and this will be gear 6. Okay, all are in one axis. Okay, so this is basically example of a compound gear train. So this is called compound gear train. So in case of compound gear train, you can write compound gear train, a series of gears are connected in such a way that two or more gears rotate about an axis with same angular velocity. Why? Because they are attached to the same shaft. Like here you can see gear 2 and gear 3 are attached to the same shaft, so they will have the same angular velocity. And so likewise gear 4 and 5 attached to the same shaft, so they will have same angular velocity. Okay, because of this. And in this case, the intermediate shafts carry more than one gears. So for this particular case, let gear 1 is the driver gear. Now N2 by N1 is equal to T1 by T2, and N4 by N3 is your T3 by T4. Also N6 by N5 is your T5 by T6. So if you write a relation, this will be N2 by N1 multiply with N4 by N3 multiply with N6 by N5 will be equal to T1 by T2 multiply with T3 by T4 multiply with T5 by T6. Okay, so in this case in this case this you can see here we can write this as n2 by n1 into n4 by n2, because 2 and 3 are having the same speed, multiply with n6 by n4, because 4 and 5 are the same angular velocity, so RPM will be same, is equal to T1 by T2 into T3 by T4 into T5 by T6. So this get cancelled out, so you have n6 by n1 is equal to T1 T3 T5 divided by T2 T4 T6. Okay, so the train value is basically the ratio of product of teeth on driving gear then divided by product of teeth on driven gear. Okay. Now we will solve one example. Example 1. Suppose one question will be given to you. Let's say just a minute, I take out the question. Suppose the question is that a compound gear train shown in the figure, figure I will draw, consists of a compound gears B, C and D, E. All gears are mounted on parallel shafts and the motor shaft rotating at 800 RPM is connected to gear A and the output shaft to the gear F. The number of teeth on each gear is given 24, 56, 30, 80, 32 and 72 respectively. Determine the speed of gear F. Okay, and the arrangement is like this. If you see the arrangement, it is like this. Okay, A is having 24 teeth and to the A gear B is attached, and with the same shaft gear C is attached. B is having teeth 56, C is having gear 30, then to C gear D is attached having teeth 80, and on the same shaft gear E is attached having teeth 32, Then to E, gear F is connected having teeth 72. Okay, so now we have the train value that is NF by NA is equal to TA TC TE divided by T of B, T of D and T of F. Okay, so this will be 24 into 30 into 32 divided by 56 into 80 into 72, that is 0.071. Okay, so here in the question the motor shaft is rotating at 800 rpm means and is connected to gear A, that means NA is given, so NF will be 0.071 into 800, that is 57.14 rpm. Okay, now we got the speed of gear F. It is a very simple arrangement. Now third category is your reverted gear train. Third is reverted gear train. Okay, now if you draw the schematic of a reverted gear train, I am drawing the front view. Okay, let's say this is gear 1 connected with 2 and with the same shaft gear 3 is connected, then gear 4 is in mesh with gear 3. So you can write here that when the first and last gear axis coincide in a compound gear train, it is called reverted gear train. Okay, it is called reverted gear train. So in case of reverted gear train, in this particular case we'll have n4 by n1 is equal to t1 t3 divided by t2 t4. This is equation 1, and if r is the piece circle radius, then r1 plus r2 should be equal to r3 plus r4. You can use these two relations to find any required unknown. Okay. For example, if a question is given to you, let's say example 2, that a reverted gear train is used to provide a speed ratio of 10, and the module of the gear is gear 1 and 2 is 3.2, and the gear 3 and 4 is 2. Determine the suitable number of teeth for each gear. Number of gear to have less than 20 teeth. Center distance between the shaft is 160. Okay, so here you have to assume assuming a speed ratio for gear 1 and 2 equal to 2.5, we have this n1 by n2 will be equal to t2 by t1, that is 2.5. Train value is n2 by n1, but speed ratio is n1 by n2. Okay, and speed ratio for pair of gears 3 and 4 is assumed to be, let's say, 4. So you have n3 by n4 is equal to t4 by t3, which is equal to 4. Okay, now another factor given to us is r1 plus r2, which is also equal to r3 plus r4, that is the distance between the shaft is equal to 160 mm. So we know that this r is equal to m1 t1 by 2 plus m2 t2 by 2. Okay, so this will be equal to 160. Also m3 t3 by 2 plus m4 t4 by 2 is equal to 160. Okay, now we have this 2 into t1 plus t2 is equal to 320 and 2 into T3 plus T4 is equal to 320, or here you can see T1 plus T2 is equal to this will be 3.2 na, this is 3.2, okay, and this is 2, so T1 plus T2 is equal to 100 and T3 plus T4 is equal to 160. Okay, so we have this relation T1 T2 is equal to 2.5 T1. Okay, so T1 plus 2.5 T1 is equal to 100. Okay, and here T3 plus this is T3, so T3 plus 4 T3 is equal to 160. Okay, so from this you can find out the gears. Okay, you will get T1 here and T3 here, then subsequently you will get T2 here and T4 here. Okay, this is based on certain assumptions. Okay, this question, right? Then we have planetary or epicyclic gear train.